This is a quick addition to the modulus functions pack based on the look of a question from a 2025 paper and what Excel do, a different example clearly, but what they do normally. So this is the last bit of your lesson 2. There it is. And the big difference between what we've seen so far and what this particular question does is this -4 here. So you started off with like a modulus function which sat on the x-axis, which is what we've always dealt with, but now we've got this translation where it's gone 4 down. So we're going to be kind of careful with that. So if we look at the original graph was 3x minus 7. So 3x has got a positive axis, positive gradient, sorry. So this is the original positive part of the graph, like a plus. 3x minus 7 minus 4. This part here is the reflection. It's the negative part of the graph which has been reflected up. So this is where the difference is. In the past, you kind of fiddled with just the sign of one side or the other, and it didn't matter. But what you're doing is you're fiddling with the sign on the modulus part only. So if you imagine, let's change colour, see if this works. If you imagine where this blue box is, it's that you're changing the sign on. So this would be like a minus 3x minus 7 minus 4. And it's that we have to be careful with. Right, so let's have a look. So it says, label the points of intersection on the graph of the coordinate axes. Right, now we can just graph it. So you can graph this on your calculator, find the roots, and it'll give you 11 over 3, and it'll give you 1. Now we know that's when y is 0. So for this part, that would be a 3x minus 11 is 0, so x is 11 over 3. For this part, it would be, let's see, so it'd be a minus 3x plus 7 minus 4 is 0. Oops. So take the 4 over, move it all around, and you get x is 1 there. So that'd be the root. So label that part, label the points of intersection. The slide says write down the coordinates of the minimum point. So before, when it was just 3x minus 7 for that part there, if I set y equal to 0, I've got x is 7 over 3. So I know that the x value, in line with the kind of like the line of symmetry, I guess you call it, is 7 over 3. But I've moved it down by 4. So the coordinate at the bottom of that will be the 7 over 3, comma, minus 4. So that would be the coordinates of the minimum. So then it says, find the points of intersection between that line and y equals 5. So if I had a line on where y equals 5 is, and I've not put that on there, but when x is 0, well, that would be, what's that going to be? 3, isn't it? There. So I know that the line there, 5, will be above it. That 3 came from, I'll try and put a little bit down here. So the y-intercept, so that's when x is 0. So that would be the modulus of 3 lots of 0 minus 7 minus 4. So that would be like a modulus of minus 7 minus 4, which is 7 minus 4, which is 3. So that bit there works out the y-intercept. Still in my head, I should work out. That's a nice straight line, isn't it? We can just straight. But if you can draw a straight line, we're really so good. And that's equal to 5. So I've got where it crosses on the positive and where it crosses on the negative. So where it crosses with the positive, we said that was plus, have a look, 3x minus 7 minus 4 is equal to 5. So I've got the 3x minus 11 is equal to 5. So 3x is 16. X is 16 over 3. So the positive part here where it crosses is at 16 over 3. The negative part, the reflected part, so I've got a minus 3x, I've got a plus 7, a minus 4 is 5. So that's going to give me, that's going to be 3. So it's minus 2 is 3x. So minus 2/3, is that right? For x? Yeah, that looks right. So that point of intersection there would be minus 2/3. So this is an addition based on the 2025 exam paper and on what Excel do. But we've moved it. We've moved it down or up. Right, that's us done. Well done, everyone.